Everyone joined? Okay. I hope everyone is there.
Yes.
Okay. So in a real world, lemma of Apple, that means it is already given a name. It is coming under named entity recognition, NER. Even if you search for some a celebrity, okay, if you are not a celebrity, just to type a name. If he or she is a celebrity, that person name will be coming first. And that is how the named entity recognition is working on a natural language processing mode. Next, entity linking. So disambiguating textual entities to unique identifiers in a knowledge base. That is why I have taken the knowledge base previous, the starting of the deep learning module. What is knowledge base? Okay. Here it is an entity linking. That is a company or any kind of an identifier is there that will be automatically linked. Next, similarity. So comparing words, text spans, and documents and how similar they are to each other. Next, text classification. Assigning categories or labels to a whole document or parts of a document. Next, rule-based matching. Finding sequences of tokens based on their text and linguistic annotations similar to regular expressions. Training, updating and improving a statistical model's predictions. Next, serialization, saving objects to files or byte strings. Okay, so these are all the common features about spaCy library, and this is how it's working. So we'll extract this information in detail in now. Okay, the statistical models on how it is going to predict your next word, and I will give you one important element over here. Okay, now what I'm just doing, I wanted to compose. I think you would have done a, right. Suppose I wanted to mail you. Okay, what I'm doing, I send them. Fine. How are you? How are you? Okay, how it is automatically coming, right? How are you doing? And I'm just adding. Okay, maybe what the regular. Yes. If I type how, the next word it is recommending you are you. Okay, and now I am asking about. Okay, how is your AML course going? So going, it's just it is giving you the recommendation based on my context. Okay, this is all based on the tools like spaCy that it is coming under natural language processing. Okay, now we'll go to the spaCy. So while some of spaCy's features work independently, others require training pipelines to be loaded, which enable spaCy to predict linguistic annotations. So whatever I have just typed you, it is the linguistic annotations, and I'll give you one more example. The Google input tools. This Google input tools, they have around 80 to 120 language preferences. You can type it over here. Okay, if if I select like this, so this many language Google is supporting, Google input tools is supporting. You can do this. Okay, now I'm just typing. Um, I'm just typing the English words, but I'm getting the Tamil word extra, exactly this to this. But also you can do in Telugu. Um, I'm just asking Tinnara, right? have you done with your lunch, or have you eaten, have you taken the breakfast, and whatever it is. So this is the back end of this information. It is like, you know um, it is uh, finding out the root word with respect to uh, the prediction of words, and also the prediction of the basic natural language processing, that too how the spaCy tools is working, the linguistic annotations, the similar kind of thing it is working. Like all these things, part of speech, tokenization, dependency, lemmatization. And by using all these things, these tools are, worked based on that. Okay, right. So a trained pipeline can consist of multiple components that use a statistical model trained on labeled data. Labeled data. It's not an unlabeled data. It's a labeled data. spaCy currently offers trained pipelines for a variety of languages, which can be installed as individual Python modules. So pipeline package in the sense, it is not, I mean, if you have multiple modules, like just assume you are working in a project in clinical trials, which consist of safety tables and also the analytics analysis table, right? So safety is one pipeline. Uh, Analytical is one more. Another pipeline number one and pipeline number two. You can combine together and you can make this as a pipeline project. Okay, so you can, if you just concatenate each and everything, maybe in the final CSR, that is how it should be, right? And the clinical study report, and that is how you are going to submit it. And everything is, it's each and every single piece of information, it's called as pipeline. So pipeline packages can differ in size, speed, memory usage, accuracy, and the data they include. Okay. So it is based on the binary weights, the lexical entries. Lexical entries is nothing but your lemmatization or the vocabulary, that is words and their context independent attribute, right? Data files like lemmatization rules and lookup tables, word vectors. Here also the vector is coming in. What is word vectors? That is multi-dimensional meaning. For a single word, we will have multi-dimensional meaning in every languages. Tamil, if you say one word, it will have multiple meanings. In Telugu also, I guess, one word, it will have multiple meanings, right? So this is one of the classification the spaCy is trying to resolve. And configuration options like the language and processing pipeline settings and model. So this is all about the statistical model, which involves spaCy library, and you can make applications using these statistical models, which is inbuilt in spaCy. Okay. Now we are going to do some of the informations. Okay. spaCy provides a variety of linguistic annotations to give you insights into a text grammatical structure. Okay. First, I think if you are in this page, just copy this page and copy and paste this code in your Google Colab and run this. Maybe I will come out of this. What do you? Okay, so I will explain and then later you'll just do it. No issues. All right. Where we are, linguistic annotations. spaCy provides a variety of linguistic annotations to give you insights into a text grammatical structure, right? Okay. This is a sentence. Apple is looking at buying UK startup for $1 billion, and this is in quotes. And before doing this, before working on this, we have to import spaCy. If the spaCy is not there, you have to install it through pip. Okay. Pip install spaCy and then do the import function. And NLP equal to spaCy.load This is en underscore core underscore web underscore sm. It is nothing but it is an English word dictionary. Okay, English word dictionary, and you are just referring, and you are loading this. After you load this English dictionary, right, you are making one document, DOC equal to NLP of, you are giving this sentence. Okay, and then you are finding out for token in doc, print token.text, token.pos underscore, token.dep. What is this all about? Token.text, token.pos, token.dep, right? Okay, we'll extract each and every information now. So even though a doc is processed, example, split into individual words and annotated, it still holds all information of the original text, like white space characters. You can always get the offset of a token into original string or reconstruct the original by joining tokens and their trailing white space. Here, each and every information is important, starting from the braces, the brackets, and then the what is that, quote, double quotes, and then you are starting the word apple, and then you are giving space, apple, space, is, space, looking, space, and it reads like this. Whatever I'm just talking right now, the dictionary reads like this only in NLP. Okay. And that is why it is called as natural language processing. It is not an artificial language processing. It is a how we are speaking and how it has been understood by the machine. In a similar way, it is trying to understand the human language. That is called, that is why it is called as natural language processing. In tokenization, okay, let's break down each and every element which is there. Okay. First, what I will do, I will show you, because yours is running, you are running a code, right? And then this. Let's see whether they are having spaCy inbuilt. Otherwise, we need to do the import, I mean, install it. So spaCy is already there. Okay, no issues. Now, if you see the information, okay, Apple, PROPN. What is that PROPN? The next word is, it is an auxiliary word, auxilium. And next, looking, it's a verb. And apple is a preposition, PROPN, preposition. And at, what is at? It is an ADP, adjective, right? So buying, it's a verb. Root word is buy. UK, U dot K dot. It is a country. It is a preposition. Okay. Now, startup. Startup is a name, I mean, noun. And for, it is an adjective. Dollar, it's a symbol. One, it is a numeric, right? And then billion, it is again, it's a numeric. If we give like this, it is giving all the information with respect to this subject, with respect to this object, with respect to its English dictionary, core dictionary, and it is giving you every information. Okay. What is special about this? Right? We have to test it, right? Okay. The first process is tokenization. During processing, spaCy first tokenizes the text, that is, segments it into words, punctuation, and so on. Okay. Sometimes, while doing ChatGPT, while prompting to Claude, while prompting to Gemini, while prompting to some other large language models, at some point in time, you will be getting a message. You have crossed your tokens, and please try after some time. You crossed your free tokens, right? That means you used all your free tokens for the particular given day. Okay. Maybe, if you are not seen, maybe try, so many documents, so many information, try working on, get the information through ChatGPT, and then you will get the message like this. That means you exhausted all your free tokens. Tokens means words. So for a particular given user per day, they will give you maximum of 5,000 or 10,000. Maybe you can also Google it or prompt it through ChatGPT. Get how many free. Let's ask okay, in the next sentence. How many free tokens that any given user any user can get from ChatGPT? In free tier, that too for GPT 3.5, right? There is a limit to how many tokens, the words or characters processed can be used daily, but OpenAI hasn't publicly disclosed. Okay. The paid plan, yes, for $20 per month. Currently, the GPT-4 Turbo, which is faster and more powerful. Token limits for the Plus plans are more generous, but OpenAI still enforces session and hourly caps to ensure fair usage. Okay, you also read this message. Okay, this is what is called tokens. All right. So, for example, punctuation at the end of a sentence could be split off, whereas U dot K dot should remain one token. This consider one token. So each document consists of individual tokens, and we can iterate over them. Okay. This is it starts from this token. So this word is totally 10 tokens. Okay. Apple is looking at buying UK startup for $1 billion. Each and everything is coming as a tokens. Right. First, the raw text is split on white space character, similar to text.split. Then the tokenizer processes the text from the left to right. Okay. And you can it's nothing. Okay. Just see this. Let's go to New York along with quotes. Okay. Prefix, exception. Let's see the color combination. The first two are gray, and then the blue, right? And then the green. How the tokenization processes this sentence. Let's go to New York. It's a word. It is processing like this. Okay. If there is, does the substring match a tokenizer exception rule? For example, don't, the word don't, okay, does not contain word space, but should be split into two tokens because there is no lemmatization for don't. So it will just replace into do and also n apostrophe t. Okay, it's a two token. This word is two token. While UK is a one token remains because it's a country name. You can't split and it doesn't make any sense. Can a prefix, suffix, or infix be split off? For example, punctuation like commas, periods, hyphens, or quotes. Okay, if there is a match, the rule is applied and the tokenizer continues its loop, starting with the newly split substrings. So this way, spaCy can split complex nested tokens like combinations of abbreviations and multiple punctuation marks. Likewise, it starts with the tokenization and also the part of speech tags, right? After tokenization, spaCy can parse and tag a given document. So this is where the trained pipeline and statistical models can make predictions of which tag or label most likely applies in this context. Okay. And if you see this, okay, I will copy this. So here, what I'm doing, I'm trying to find out the token of text, token of lemma, token of POS, token of tag, and each and every shape, whether it is an alpha, beta, something, or star. Okay. Let's just see this entire element. Okay. This is how we are getting the response from any NLP devices, even the audio. This is how it works. If you are talking to your Alexa device, this is how it is trying to split. If you are talking to Google search engine, this is how it is devising. Okay, right. This is how the table of column. Text, lemmatization, part of speech. It's a grammar, right? It's a proposition. Tag. Maybe take it this as a homework. What is this tag is all about? What is this, it is getting in? How it can be referred? And what is DEP? What is shape? Right? What is alpha? And is it a stopping sentence or what? Is it stopped over here or it will continue? Apple. It is not it is not stopping there itself. It is continuing. So that is why it is false. So likewise, you try to understand and also try to have the relationship between this and how the sentence is just, getting into. And then name the entities. That is NER. Okay. If you just run this, all right, entity, ent.text, ent.start character, end character, label, and everything. Okay. And I'll just copy and done. The text, entity text, and then start character, end character, entity label. This is a organization. ORG, it is an organization. UK, right? Where it will start, what is the starting point of this character, the ending point of this character, and this one. Okay. So likewise, you'll be able to understand how the natural language processing happening under spaCy library. Okay. And also like word vectors and similarities. Just to go through this, all right. Run all the codes and also try to see the architecture, vocabulary, and everything, training. Okay, there are so many things are there, tag, tokenizer, parser, creation, and everything. Okay, so this is architecture. It's very simple and effective, and how it is just designed to help you out. Okay, you can do a lot of things. And if you just and moreover, based on this spaCy, I will show you one more thing. Sentiment analysis. This is the problem statement. So Twitter text sentiment analysis using spaCy. Okay. And also using spaCy, you can also get uh, Amazon. Sentiment analysis using, I mean, easy to use. No, using spaCy. I have already gone, yeah. Classification. Using a spaCy library, you can understand the emotions of feedback, whether it is positive feedback or negative feedback. You can just take this as a homework. It is very very simple code. Okay, so really very nice to work on this kind of a code. And also you can work on Twitter analysis. You can work on Amazon analysis. You can work on IMDb, that is a movie recommendation engine. You can work on it's and also if you have a WhatsApp group, you can also trying to understand the sentiment of that WhatsApp group. Okay, so sentiment classification, it has been broadly analyzed through spaCy library. You can also work on. Okay, so through this you can do lot of other things as well. So this is how the starting place of natural language processing, and it has been classified like this. And there is one more, very basic library. It just started. Okay. So if you just go to the pomegranate, okay, pomegranate.org. Um, it is one of the basic library. Yeah, you can also work on org. Let's see. So that pomegranate. What is that? They're having very, that is a starting point of NLP. Okay, so you can also work on this. It is a starting point, and pomegranate library is a starting one, and then the next is spaCy, and next is, you already know, that is a Gen AI evolution and revolution, that is large language models. From there we are going back and forth, like creating so many applications: text to text, text to video, text to audio, text to video, text to animation. There's so many APIs that are coming in. This is a starting point of application programming interface, and this is a starting point of any projects can be done just like that. Okay, just go through this spaCy very well and try to understand how it is run. And from this place onwards, we are using advanced deep learning process. This is starting point. Okay, using this, you'll be able to, as I shown, you'll be able to create sentiment analysis. You'll be able to create a lot of other things as well, language translation, right, and so on. Okay, so this is a very great innovation in the field of natural language processing. Okay, so just try to understand this concept, and maybe next week, we'll move on to the Gen AI process. So, after visiting the RNN, recurrent neural network, and then we'll be going to a Gen AI process. After the Gen AI process, we'll be doing the going with projects. Gen AI project, how to do the Gen AI project using Grok Cloud. Yesterday we discussed most of the information, and Hugging Face, using Grok Cloud, Hugging Face, how we will be able to develop a project. So that would be the end of our the sessions, and I will give you the problem statement. Please try to work on within the specified time, right? So this is how the plan is going to be. Okay. Any questions?
No questions, any. We will look into that spaCy.
Yeah. spaCy is an interesting tool, and it has been used in many ways. Still, there are companies they are using spaCy as their backend model. Even though we have an advanced model like Gen AI, because the potential of the prediction, that is why spaCy still exists in many models. Okay, go through all these things, and and yesterday I've shared the yesterday's recording, and I will share today's
The
recording.
previous recording also you shared, right? Previous recording also you shared, right?
Recording, and I will download it from the drive, and then I will share it. Okay. And,
Okay.
I will just download it and I will share it. So, okay. Thank you so much, and yeah, keep working on this, and let me know after completion of that CNN how it is predicting.
Okay. Sure. Let me see how long it is running. 65%. 65%.
Yeah, because 8,000 images.
Yeah, 60%. But after 65%, then we have to run that the remaining one. You have
remaining
to see
codes. Yes.
Data processing. Okay.
Yeah.
So what is the idea like prediction? We are going to make a single predictions kind of.
Yeah, you are going to make a single prediction by giving one image. Okay. And then whether
it is taking automatically, that image automatically it will take.
I think so. We have to check it. We have to check it. How it is taking, yeah. Check and maybe we'll work on it. And I will send you the corrected one. Let me see. The one email is sent. Okay. Let me open this code. Okay, I will share this code as well. Okay. And then we'll be I'll download this. Download. I've shared the code as well. Maybe you can try this code. Done. Okay. Let's see how you are.
Through mail you sent.
WhatsApp. They're also trying to. So they are unzipping like very simple code. You can change wherever possible. You can change the location. Okay, it's possible. Okay, just Take care of the location and then try. Okay. Okay. And try it and let me know whether you'll be able to run it fast. Right. So thank you so much, and we'll meet next week.
Have a great day.
Okay, bye.
Good.